Alrighty, hello. This is going to be a little goofy because I'm going to be switching back and forth between the face cam and my document camera. So bear with me. This is supposed to help with doing checkpoint 3 if you are unsure of how to get started on the modeling. So I'm going to go ahead and share my screen here, and I will be talking a little fast because I want to make sure this video is not too long. So if you need to end up watching it more than one time, or emailing me to clarify something, go for that. Okay, so when we're doing our modeling, here are some of the expectations for all three parts of the modeling. We want to make sure we have the appropriate element symbol. And if there's more than one of that atom, of that type of element, we want to have it. The relative size of atoms, you'll see more what I mean in just a moment. And then a solid line to represent a single or two lines or three lines, double or triple bond when we get to bonding and molecules. Now, the best models will include labels with units for atomic radius and for bond length, and you will have the size of atoms and bonds to scale. Now, I will not be showing this because it just takes a little too long, and I don't want to make this video be too long. That being said, on your checkpoint, you will have to model single atoms, model bonds, and model a methanol molecule. So what I'm going to do in this video, let's see if this works. Oh, no, I got to go back into Zoom first. Let's see, maybe I'll stop sharing and then boom, look at that. So the first thing we're going to do is model one atom. And for this example, I'm going to actually model two so that you can see the size difference. So the first one I'm going to model, and pardon me for being left-handed, is fluorine. I'm going to model fluorine there. It is the element F, and I'm going to go ahead and use the checkpoint. I'm not going to switch the camera for this, but you just have to trust me that on the checkpoint slide 3, I can see that the atomic radius, if my hand's covering this, I apologize, but you'll be able to see it. The atomic radius is 57 picometers. And a picometer is super ridiculously small, but you don't need to worry about that because all of them will be listed in picometers. So as long as you know whether 57 or some other number is bigger or smaller, you'll be okay. So the next thing I'm going to do is get a circle drawn because I'm not going to go for a 3D representation. I'm just going to go for a 2D one. So we've got our atom with F in the middle because it is a fluorine atom. And then sometimes it's smart to take a different color, although this is definitely not required. But I'm going to do it just to differentiate, and I'm going to draw a radius. And honestly, that's probably not perfect. The center might be a little bit up, but then go like that. And I can say 57 picometers. And so that has now been labeled. That is a fluorine atom. Next, I'm going to do a chlorine atom, Cl. Remember, y'all, this is always Cl, never Ci. And once again, I can go ahead and check the atomic radius of this on the checkpoint data slide 3. And it looks like our atomic radius, I'm going to abbreviate that AR, it's going to be on a little bit quick here, is 102 picometers. Now, if I think about it, 57 and 102, now it's not exactly one half of this, but it's pretty darn close. And so what that means is I definitely need to make my chlorine atom larger, right? 102 is larger than 57. And if possible, I want to make it around 2 times larger. Now, I will not pretend that I am any kind of like super phenomenal to scale artist, but I think that looks like about 2 times. And then once again, I'm going to get a different color and try and get a radius drawn there. And that would be pretty good for our drawing an atom. Oh, let me get that up there a little bit. Sorry, y'all. The issues of trying to do this on the multiple cameras. but there we go. So before I move on here, I just want to quickly go over the fact that you can see each atom has been drawn with a circle to represent the outside of its electron orbit, the element symbol representing the nucleus, and then the radius drawn in and labeled with the atomic radius. So that's modeling for an atom. Let's check it out for modeling one bond. Now, for this one, I am going to do still actually just one example. And in this case, you kind of have to do modeling the atom before you can model the bond. So I'm going to model an HCl bond, and hopefully you recognize this. We worked with this as an acid last project, hydrochloric acid. And like I said before, I think first I'm going to draw just the atoms so I can see H 31 picometers, Cl is 102 picometers. So once again, I think about this, this is going to be about 3 times larger. So even so, I'll get my H and I'll get my Cl. So I've got my 2 atoms here, and instead of drawing in the atomic radius, I'm going to think about how big their bond would be. And this is where it gets not really tricky, but kind of cool in my opinion. To know how long the bond is, you can usually just take the atomic radius of one and the atomic radius of the other and add them up. So that's 133 picometers. And so that means that from the center of chlorine to the center of hydrogen should be about 133 picometers. Now over here to the left, I'm just going to show what it looks like when we put it all together. So I've got my H, and then I've got my Cl, and they don't necessarily have to be touching. That's actually like an extra level of detail that we may or may not go into, something Dr. D and I discussed a lot. But then now I can take a different color, oh, that's kind of nice, and draw from center to center, and I will want to label that. Bond length, and eventually you can probably just abbreviate it as BL. Bond length is 133 picometers. So boom, we've got our atoms drawn, the element symbols in the middle, a bond drawn to show that they are bonding, and the bond length is labeled. The atoms are drawn relative, not to scale, but chlorine is clearly larger than hydrogen. And that is what we are going for. So that's part 2. One last part, you can see this here because I was experimenting with making sure the camera would work. And let's see. Yo, thank you for sticking with it so far. I promise it is worth continuing if you are struggling with this checkpoint. Thank you. All right, so for the last one, this is kind of like putting everything together now. We're not doing just atoms and we're not doing just a bond, we're doing a full molecule. So I am going to do CH2Cl2, which if I were to draw this as like a skeleton structure, that's one of the names we could use, it would look something like this. It would look like a C, an H, and a Cl, and a Cl, and an H, something like that. But we want to model it to show the respective sizes of the different atoms. So I think it would be smart for us to at least get one of each atom type before we start putting our whole molecule together. I've already drawn an H and a Cl, but I haven't drawn a C yet, so let's check this out. So We've got our H, which is 31 picometers. We've got our C, which is 76 picometers. And we've got our CL, which is 102 picometers. So once again, when we are putting our molecule together, you can really just build it bond by bond. And if we think about this, we could probably use this structure and pre-label what the bond lengths will be. Like C to H should be around 107 picometers. That should be about 107. And C to Cl, we haven't done yet. That should be about 178. Now, this is really just taking notes. This is not our answer. Since carbon's in the middle, I'm going to get that drawn first. And there is a chance, y'all, that my drawing goes out of the window, but if that happens, we will be all good. Then I've got a little H, and a little H, and a larger Cl. And I'll admit, I didn't do a great job of making the chlorine much larger than the carbon, but I think I would still say it is clearly larger. So we'll see if I can do a little bit better of a job at emphasizing the size difference there. I think you might say that that is a little bit larger. Now, to really get home the fact that we have different bonds here, I'm going to use different colors, and that is super not necessary, but it can be nice. It can make your model easier to understand, easier to read, and then it would be smart to label each bond type at least once. Like I said before, we can abbreviate bond length with BL, save some space, make sure it doesn't look so cluttered. So my C to Cl is 178 picometers. And my C to H is 107 picometers. And that is my model for a molecule, this is, I think it's called dichloromethane, but that's not really important. What is important is that this is what you need to do on your checkpoint. So this video has gotten probably too long, but I wanted to be there to help y'all out. I really do hope that one or many of you watch this and feel like you are more prepared to do the checkpoint. All right. Thanks.